Okay, so today we're going to quickly review factoring, and then I'm going to give you some time to work on your own. During that time to work on your own, if you get stuck, you ask for help, okay? All right, let's go. Factoring. The first question, and these are notes. If you want to take them at the bottom of the sheet, you're welcome to. If you want to put them in a notebook, you can do that. The first expression we see is 10x squared minus 25x. When it says factoring, we're breaking this polynomial expression down into its factors. Now, when you were in elementary school, you learned about factors. Factors are things that we can multiply to get something else. Like the factors of 12, 1 and 12, 2 and 6, 3 and 4. All those make 12. So this is the same thing, but now we have polynomial expressions. So we have some variables. We have letters in there that mess with us sometimes, and we're gonna kick them this year. All right, so here we have 10x squared minus 25x. The first thing we always look for is, does a polynomial expression have a greatest common factor? Is there something that can divide into the terms that are there? Is there a number that divides into 10 and 25? 5. Yes. So we're going to factor out that 5. All right, and then the second part of asking ourselves this question about the GCF is, do these terms have a variable in common? Yeah. They both have what? X. Okay, so this is, if you're reminding yourself, this is GCF, and this is what we look for first every time we factor. Is there a number that divides into all my terms? And is there a variable that they have in common? Okay, so once I factor this out, I say, okay, what do I multiply 5 by to get 10? 2. Here I have 1x, but here I had 2. So what do I need? I need another x. Very good. And then we say, all right, 5 times what is 25? 5. This one has an x. This one only needs 1. I'm done. And the check step, anytime you factor, would be to distribute back and see if you get what you started with. Okay, so that is the first thing we look for every time, GCF. Now, problem number 2, example number 2 for today. We did a lot of these in geometry. This is a trinomial, and the leading coefficient is only 1. It's an understood 1. So, if it's factorable, this is the easiest kind of factor. All right, who remembers? How do we factor this one?
45x squared.
Okay, you want to do it multiplying? I gotcha. Can I hold that off for just a second? You want to do the x?
Yeah, that's what
you want to do the x? Okay. Alright, so if it has a leading coefficient of 1, we can kind of take a shortcut, but that other way always works. So you would say, what do I multiply to get the 45 that I can add to get 14? Okay, now you don't have to draw the x, but sometimes the x helps us to see it. What can you multiply to get 45 that you can add to get 14? What do you think?
9.
9 and 5. So we would factor this to x plus 9 times x plus 5. Okay, so whenever that leading coefficient is that understood 1, this works. And we could distribute back and make sure we get what we started with, x times x squared, x times 5, 5x, and then do 9 times x, 9x, 9 times 5, 45. So this is x squared plus 14x plus 45. Did we get what we started with? Yes, we did. So that was our check step. Okay, any questions on GCF? or factoring a trinomial with a leading coefficient of 1. Okay? Alright, now this one's not a trinomial. What do we call it when it only has 2 terms?
Binomial.
Binomial, very good. And this is a special binomial because with this binomial, that first term is a perfect square and the last term is a perfect square. Does anybody remember this? A difference of squares. Okay, so this is a difference of squares. And a difference of squares factors to the square root of the first one plus the square root of the second one times the square root of the first term minus the square root of the second one. And the reason this always works is because if we were to distribute back through, we get a positive 4x and a negative 4x, and they cancel that middle term out. So that's a difference of squares. It works when you have a perfect square minus a perfect square. That's when we do this. Okay, so if we're thinking perfect squares right now, this one looks like a perfect square because 4 is 2 squared. This one looks like a perfect square. 25 is 5 squared. So this is called a perfect square trinomial. And it factors to a binomial squared. So what is the square root of 4x squared? 2x. What is the square root of 25? 5. And then if you remember from last year, we always do the sign of the middle. Now, our check step for this one is a little different. Our check step, what we do is if we double this product, if we double that product, it should equal this middle term. Okay, so what is 2x times negative 5? That's negative 10x. If I double that, do I get the middle term? Yes, it checks. Okay, you probably didn't spend as much time focusing on these special ones when you did factoring, but you probably spent a lot of time doing ones like number 2, and you probably spent a lot of time doing ones like number 5. So this time we have another trinomial, but it's not a perfect square. 18 is not a perfect square, 2 is not a perfect square. It doesn't have a GCF either, because 2 doesn't divide into 15. So, how many of you learned this doing trial and error? Just one. Okay. Then maybe I won't go over trial and error. I'll do it the other way first. All right. So, when it had a leading coefficient that was not 1, what we do is we take this and multiply it times that. Do y'all remember doing that? Okay. So 2x squared times positive 18 is positive 36x squared. And we do the same kind of thing with the x, but we have to use this 36. What can I multiply to get positive 36 that I can add to get negative 15? Anybody have an idea? That's it. So we're going to do 12 and 3. And since we're multiplying to get positive and adding to get negative, it's negative 12 and negative 3. All right, so what we did any of your teachers call this term splitting? you would split that middle term into negative 12x and negative 3x. Alright, so we'll look at the first two. The first two are always going to have a GCF now. What is the biggest number that divides into 2 and 12? 2. What variables do they have in common?
X.
X. And when we factor that out, just out of those first two, what are we left with? X minus 6. Okay, so we want this to match. We want this to be x minus 6. So what has to divide out of this? A negative 3. Alright, so our last step is to where we take, alright, these two they have in common. I'm going to pull that out in front. And then I'm going to group what's left. Okay, I'm going to show you trial and error. Because it's really the quickest way if you're okay with multiplying. Now, if I ask you what 6 times 8 is, and it takes you like 4 or 5 seconds to answer that question, this is not the way you want to do it. Because you're not as good with that kind of mental math. But if you're pretty good with mental math, then you want to do it this way because it's quicker. There is only one way to multiply and get 2. 2 times 1. That is the only way to multiply and get 2. Now there's a couple ways to multiply and get 18. We can do 1 and 18. We can do 2 and 9. Or we can do 3 and 6. We have 3 possibilities. This is called trial and error because you have to just kind of guess. We're multiplying to get a positive and adding to get a negative, so we know they have to both be negative. That's the only way to multiply and get a positive and add to get a negative. And I know that when I distribute, this product and this product always give me that middle term. So if I put a 6 right here, do you see that gives me negative 12x? And if I put the 3 right there, that gives me negative 3. And what is negative 12 plus negative 3? Negative 15. So there's my answer. I'm done. Did I get the same thing? Yeah, I did. Now, on this one, the x minus 6 came first. On this one, the x minus 6 came second. Does that matter with multiplication? No, because 2 times 5 is the same as 5 times 2, isn't it? That's called the commutative property multiplication. If we switch the order, we still get the same product. Now, we can't switch around the signs. Do you see how the signs match? The signs match. We can't switch around the signs, but we can switch the order of the parentheses. So tomorrow when I put my answer key out, and I have x minus 6 times 2x minus 3, and you have this, we're both right. Okay? All right, you have the rest of class to work and ask questions. I'm going to cut off the video at this point, so feel free to ask questions.